So now we're at example 2, where we're supposed to be sketching a graph with horizontal and vertical asymptotes. Again, this is a revisit of some stuff that we've done earlier, so you can use your cheat sheet to review what we're looking for horizontal and vertical asymptotes. This one's actually, we can figure out the horizontal asymptote right away because we notice that we have an x squared over an x squared, and when we have that scenario, these guys are the same. Doesn't matter if it's x over x, x cubed over x cubed, whatever. As long as the degrees are the same top and bottom, then we're going to have an asymptote at y equals the number. And in this case, this is a 1. So at y equals 1. So we can go ahead and put that in right away on our graph. This is our one line. Then we can just, oops. Make ourselves an asymptote, and there, we've got our horizontal asymptote done already. Didn't really have to do any work. Now to move on to the vertical asymptotes, though, that's going to take a little bit more because we have to factor this. We're still looking for the non-permissible values. Obviously, if we've got x squared up here, we're not going to have any common factors, so we're not looking at a whole situation here. What we're going to do instead is factor that. So I've got my y equals, and I can just leave the x squared up top there. This is just an x squared. There's no number here, so I don't have to do decomposition or anything fancy. I just put my brackets in. X squared is x times x. And then I have to ask myself, what are the factors of negative 8? So I've got 1 and 8, 2 and 4. Yeah, that's it. So it's a negative, which means I'm going to have a negative and a positive. I have to have a difference of 2. So I have to look here for a difference of 2, and yeah, there it is. Positive wins, so the big number has to be positive, which means this has got to be the negative. And therefore, when I put my values in here, it's going to be minus 2 and plus 4. So now I'm going to look at what the non-permissible values are for each of these. And I've got x minus 2. So 2 minus 2 would give me 0, so x can't equal 2. And here, x can't equal negative 4, because negative 4 plus 4 would be 0. So those must be my asymptotes. Let's make those 2 different colors so that when we put them on the graph we can see which one's which. So I'm just going to make this one green. X can't be 2. And this one's red. X can't be negative 4. I go over to my graph. If x can't be 2, then I go 1, 2. There's got to be a line here going horizontal or vertically down the page. There's one of my asymptotes, and x can't be negative 4. So I count back 1, 2, 3, 4, and I'm going to make my line there. Beautiful, look how pretty that is. Now, where do my lines go? I don't know. They could go this way, they could go any way. And the only way that I've got to test that is to actually throw in a value. So let's see. The easiest thing to do is to throw in a value that's near the asymptote, because that's where the really obvious behavior is going to be. So I can make myself a table, and I'm just going to make x values and y values, and I'm going to choose values that are around the asymptotes. So I'm going to try negative 4.01. That's really close to negative 4. Should give me a really good feeling for how that's going to behave. Some other ones I could try on the other side of that asymptote would be negative 3.99. And my other asymptote being positive 2, I would want to try 2.01, 1.99. So all I'm going to do is take this value and plug it into this equation and use my calculator to evaluate it. So when I do that, I should get 268 here. If I were to plug negative 3.99 into this equation at each of the x spots, then I should get negative 266. Then I'm going to do the same thing with 2.01 and plug it in, and I'll end up with 67. Whoops. Yep, that's right. And negative 66. So if you have trouble plugging this in to that equation and getting this value, you're going to need to let me know. I'm just going to trust that you know how to use your calculator at this point, and I'm not going to write it out here. So contact me if you have any trouble with that part. Once we've got these points, then we're just going to plot them. So I've got, if x is negative 4.01, so if x is just slightly on the more negative side of negative 4, then the value is really high. So that means that at this asymptote, where x equals negative 4, the value for y is very, very high, which means that this is going to have to come down and go like that. So I've tested that value. I know it can't touch my asymptote here, so it has to do this. There's no other option. If I go to negative 3.99, which is on this side, I can see that this is a really big negative value, which means that this one is going to have to be coming up from the negatives and approaching and then turning here. So when I go to the next one, at my asymptote of 2, at 2.01, so on the far side, it's really high up, so I can assume that it's going to do that. At 1.99, which is on this side, it's really low, so I know that it's doing this. So what we don't know is exactly what's happening in here, and even though this is a sketch, we kind of want to get a little bit better idea of what's happening in that area, so we can try to use a value that's going to narrow down what that part looks like. So I can try x equals 0. That'll give me an idea of whether or not, or what's going on in there. If I put x equals 0 into this equation, then I'm going to get 0 divided by negative 8, which just gives me 0. So I know that it's going to go through this point. If I want to try and see if it goes beyond that point, I can try another one. But I'm going to let you guys play with that a little bit. Basically, if you want to narrow it down, you can just plug in values that are in this area, and then you'll see where they go. But it's going to be something like that. And again, it's a sketch. So I'm not going to be bugging you guys about nailing it down exactly. I just want to be able to see that you understand the concepts of where the asymptotes are and how to figure out how the lines act on either sides of them.